What's up, everybody, and welcome to this week's flipped lesson. This week we're going to cover percent and interest problems, so make sure that you take good notes and listen carefully so that you catch the phrase of the day. We need to start with some vocabulary to make sure we understand how to translate English into algebra. Just two basic words that we're going to cover, and that's of translates into an algebraic equation and multiply, and is means equals. In our first examples, we're just going to take percentage problems, translate them into equations, and solve for the unknown value. In our first example, 15% of 180 is what number? 15% translates into as 0.15, so we move the decimal 2 places to the left. Of means to multiply, is means equal, and what number is assigned by our variable. So 0.15 times 180 equals x. We can solve this value by multiplying, and we get x equal to 27. So 15% of 180 is 27. Next, we're going to change it around just a little bit. We have 23 is 25% of what number? So 23 is means equals, 25% gets expressed as 0.25, of means to multiply, and what number gets assigned as our variable. We solve this equation by dividing by 0.25, which gives us 92. So 23 is 25% of 92. In our last percentage problem, what percent of 64 is 68? X gets assigned what percent, of means to multiply, and then is means equals. So we have x times 64 equals 48. We've solved this by dividing by 64 and simplifying to get 0.75 or 3/4. Since it's asking for a percentage, we provide the answer as a percentage of 75%. So percent problems are easily solved by translating into equations and then solving the one-step equation. As we move on, we're going to get into some word problems and identify the percent of change. In order to do this, we need to learn a new formula. So whenever a price is changed, we can find the percent of increase or the percent of decrease by using this formula, and it's given as the percent of change over 100 is equal to the change in price over original price. That's percent over 100 is equal to change over original. One of the challenges is identifying the change of price. The change of price is identified as the difference between the original and the new. Keep in mind that the change in price should always be expressed as a positive number. So in the first problem, we're going to identify the percent of change. So our problem reads, the cost of Padre tickets last year was $20. The cost this year is $12 because they're horrible. What is the percent of decrease? So the change in price is 20 minus 12. That gives us a value of 8. So we have x over 100, and our percent of decrease is identified as our variable of x, because that's what we're trying to solve, is equal to 8 over 20, because 8 is the change in price, 20 is the original price. So what we have here is a proportion that can be solved by finding the cross product. Cross product gives us our equation, which solves to x equals 40. So we have a 40% decrease in the price of Padre tickets from last year to this year. In our next problem, we're going to find the original price. We know that Bob pays $27 for a gym membership. This was an increase of 8% from last year. And what we want to find out is last year's price. Last year's price is represented by the original price. And since that's what we're trying to find out, we're going to assign that with the variable x. We know that there's an 8% increase. So what's tricky about this problem is calculating the change in price. So since we know that he's paying $27 now, and he paid X dollars last year, the change in price is going to be assigned the expression 27 minus X. So note that the change should always be positive. So now the equation is going to be 8 over 100 equal to 27 minus X over X. Finding the cross product here gives us 8x equal to 2700 minus 100x, which solves to x equal to 25. So last year's price for Bob's gym membership was $25. Now we're going to switch gears a little bit for our last problem and calculate some simple interest. Stephanie invests part of $6,000 at 6% and the rest at an investment that yields 11% interest. Her total annual income for these investments was $460. What we need to find out is how much she invested at 6% and how much she invested at 11%. Now to do this, we need to understand that the amount invested times the interest rate is going to equal how much money that she made, which is her income. So when we solve these types of problems, a table is always helpful to organize our information. So we have the amount times the interest equal to the income, and we know the investment is split up into a 6% and an 11% investment. So we need to generate a variable. And it doesn't matter if we assign the variable to 6% or 11%. So we'll go ahead and give it 6%. Now, one of the challenges of this problem is expressing the amount of money that we invested at 11% without creating a second variable. Since we know that $6,000 was invested at, or $6,000 was invested total, and X dollars was invested at 6%, if we take away the amount of money that was invested at 6%, what we'll have left is the amount of money that we invested at 11%, 6,000 minus X. We know the interest rate, so we put those into our table as decimals at 0.06 and 0.11. Multiplying straight across gives me the expressions that we're going to use in the equation. So if we take the amount of money that we invested at 6%, the amount of money that we made at 6%, which is 0.06x, and the amount of money we made at 11%, which is 0.11 times 6,000 minus x, and add them together, that equals $460, which is our total income from the investments. Here's the equation that's going to answer our question. So we distribute, let's combine our like terms, and solve it, and we end up with x equal to $4,000. So what that tells us is we invested $4,000 at 6%. 6,000 minus 4,000 leaves us with $2,000 to invest at 11%. So that's our flip lesson for the week. And for our phrase of the day, eat more vegetables.